All right, let's actually go back to what the two functions were that we looked at in the first video. And now let's apply the product rule now that we've derived it to find the derivatives of the two functions. So the first function we looked at was f of x equal to, and I gave you two factors multiplied by each other, 3x minus 1 times 4x plus 2. And I want to find f prime of x. Now then, what I told you you couldn't do the first time we looked at this before we knew what the product rule was I could not take the derivative of this, which is 3, times the derivative of this, which was 4. What we did instead was we multiplied it out, got it as a polynomial, and then applied our other rules. But I can apply the derivative, the product rule rather, to find the derivative of f of x. So f prime of x is equal to, if we think about what the product rule told us to do, it said keep the first function. So if I think of this as the product of two functions, I'm going to keep 3x minus 1, but I'm going to multiply it by the derivative of the second function, which is 4x plus 2. So that's the first function times the derivative of the second, plus, now I'm going to have the second function, which is 4x plus 2, times the derivative of the first function, 3x minus 1. So now let's do some simplification, actually take some of these derivatives. So f prime of x equals, again, this is going to be 3x minus 1. The derivative of 4x plus 2, well, the derivative of 4x is 4, and the derivative of the constant 2 is 0. So I get 3x minus 1 times 4. Plus, I'm going to keep 4x plus 2. The derivative of 3x minus 1 is going to be just simply 3. And now if I do my simplification here, if I distribute 4, I get 12x minus 4. And if I distribute 3, I get plus 12x plus 6. And if I simplify that further, I get f prime of x is equal to 24x plus 2, which was the result we anticipated getting. That was the exact same result we got when we multiplied it out. And so you can kind of see from the process that it is still easier if you have a function like this to go ahead and multiply it out, get it as a polynomial, and then take the derivative of the polynomial. That is still easier than doing the product rule, but the product rule does hold up. Where we have to use the product rule was for that second function that I gave you, which was g of x equal to x squared times the sine of x, and we want to find g prime of x. When we looked at that function, one of the things we said is, hey, there's no algebraic way to turn this into a polynomial like there was for this one. So this one does require the use of the product rule. But it's not a bad one to use as long as your bookkeeping is good. The product rule is usually pretty straightforward. So the first function is going to be x squared times the derivative of the sine of x plus the second function, which was just sine of x, times the derivative of x squared. So now we just need to take the derivative of sine, which we know from the previous lesson, and the derivative of x squared, which we know from earlier in this unit. And so we get x squared. The derivative of sine of x is going to be cosine of x plus the sine of x times the derivative of x squared we know to be 2x. And there's several ways that we can write this. I can say that g prime of x is equal to x squared times the cosine of x plus, if I just kind of, to get things the way normally we write these as mathematicians, moving the 2x in front, we get 2x times the sine of x. And there's your derivative for g prime of x. For g of x, there is the derivative g prime. One of the things that we can do in terms of writing this, and this actually comes up, one of the things that, just to kind of give you a little bit of forecasting what's going to happen later on in this unit, or later on in this semester rather, is we at some point might want to know where g prime of x is equal to 0. And so if you can take out common factors, that a lot of times is very helpful. And so I can rewrite g prime of x as, if I can take out that common factor of x, and then if I rewrite it, I get x times the cosine of x plus 2 sine of x. Either one of those statements are equivalent. They're both g prime of x, but just kind of know that there might be a day in the future where writing it in this second form would be something that's beneficial to us. But we'll cross that bridge when we get to it. Either one of those two responses are acceptable.